Okay, welcome back. So in this lecture we're going to talk about cursors, which are a method that allows us to access data inside of our feature layers or shapefiles or geodatabases, such that we can basically do three things. We can retrieve data with a search cursor. We can insert new data with an insert cursor, and we can update or delete with an update cursor. So these are, if you've worked with databases before, these are similar to getting a data table back from a database and then doing stuff with that data table. So they allow us to access our shapefiles or our layers in much the same way as you would access a table. So this is handy because a lot of programmers are familiar with working with databases this way. So to be able to work with your geographic data in the same way provides familiar way of doing it, even though you're working on more complicated GIS data. So let's go through these one by one. They're not too complicated, so hopefully we do a good job. So insert cursor allows you to insert data into an existing feature class. So it's pretty simple concept. What we do is same as always, we set up our file exactly the same with import arcpy, setting the location to our geodatabase that we're working in. We use the R for raw string so we don't have to mess with our slashes and escape them. Then what we're going to do is we're going to create basically a record that is going to be inserted into our existing layer. So we are going to put this new layer into, put this new feature into an existing feature data source. So what we're going to do is we're going to make, in this case, a tuple, right? Because we're using the parentheses with the attributes that we would like to insert along with the data row. So what we do is the first attribute or first parameter in this case is going to be the name of the feature, and the second is going to be the latitude, longitude, location, and in this case it's actually longitude, latitude, because shapes in most things are XY, not YX. That's something that will mess you up to no end, is that XY is not actually lat long. XY stands for long lat. So you'll see it from time to time in weird places as long lat, even though it's more commonly spoken as lat long. I don't know why. But XY is actually long lat. So lat long is actually YX, which doesn't work well in most cases. So what we are going to do is create this tuple with the information that we want. It's a tuple because that tells Python that it's immutable. So it would be more challenging for the system to be able to insert a list which could be changed from time to time. So we make an immutable data object or immutable variable indicating that none of these things will change. Then what we're going to do is we're going to create a variable named insert cursor. It can be named anything. Naming variables insert cursor for insert cursors is common, and you'll see that in a lot of example code. And this is inside of arcpy.da for data access.insert cursor. Then we have to provide it the location of where it's going to go to. So this is going to have a imaginary feature class inside of our campus geodatabase named Albritton. So this would insert a new row into the Albritton feature class inside of our campus geodatabase. And it's going to insert these values, so the name of it and the location, into the columns specified by the building name column and the shape column. So in this case, we're inserting a XY coordinate. So the name of that column inside of a feature class, even though it's an imaginary column, or sorry, it's a real column because the geometry is in there, but when you look at the column names, it's not going to exist. So it's sort of a behind the scenes column. That one is called shape at XY. So what we do is we specify the attributes we would like to be inserted, and then, or the data we would like to be inserted into those attributes. And then for our insert cursor, we have to tell it which columns are going to get filled by those data fields that we just made. Right, so we set up our insert cursor, tell it where we're going to insert to and which columns we're expecting to insert data into. And then now that we have our insert cursor, we can do insert cursor.insert row and pass it in that tuple. And it will go to this feature class inside of our Geog database, and it will add a new row. So that's basically it. So when you finish working with cursors, so the biggest pain in the butt part that you're going to run into is you always have to delete your cursor. If you don't delete your cursor, then Python keeps it hanging around as a variable, and that locks your feature layer. So we talked about closing files after you open them, otherwise things get locked. Insert cursors and search cursors and update cursors are the same way. So after you make and use a cursor, you have to make sure to delete it. Otherwise, you're not going to be able to work with that layer anymore until your Python program exits, which, you know, might get stuck even for a little bit after that. So that's basically it. So set up ArcPy and location of your Geog database, make basically an object with variables inside of it or attributes inside of it that you would like to insert. Set up your search cursor with where you would like it to insert into, so which feature layer, and then which attributes you plan on inserting. And then you just call insert cursor.insert that object that you created. So this is a way that you could loop through a GPS coordinate file of latitude, longitude, locations and add them to an existing shapefile class. We've seen lots of other ways to do the same thing, where we create an event layer and then we save that event layer as a new feature class. This works particularly well if you have an existing data layer and you would like to add more data into it. So this is the proper way for doing that. So if you have an existing data layer already with XY points in it, every morning you get a new file that you need to append to the end of that. You would use an insert cursor for that. All right, next up is a search cursor. So you can probably take a guess what this one does. This one searches for data inside of a data layer. So we have two different versions of it here, just to show the different way that you can iterate through them. The more common way of doing it is the first one, where we use a for loop to search through all the rows that are coming back. The less common way is to use a while loop with the next function on a search cursor. So when we learned about iterators and how to build your own iterator, we saw that you can make anything iterable as long as you override the correct _, functions in the class definition. So you can loop through a search cursor just like an iterator, or you can loop through it using a for loop, which calls the iterator under the scenes. So let's take a look at this. They're both going to start same old way, importing ArcPy, setting up your location of your Geog database with a raw string, so that way we don't have to do anything weird with our slashes. Now we're going to make a list of which fields we would like to return as the result of doing this search, because you might not want to have a gazillion fields coming back when you're querying your data layer, your feature class or your shapefile. You might just want to have only the fields you need, so that way you don't have to worry about indexing and all that kind of stuff. So first thing we need to do is specify a list, not a tuple, a list with square brackets of the fields we would like the search cursor return. Then we create a search cursor variable. Naming it search cursor is helpful. And it lives inside of arcpy.da, and its constructor is called search cursor. And we pass it in the location or the name of the layer we would like to search, as well as the fields we would like returned. We have seen this in prior lectures, taking a where clause. So you can also pass in a where clause to limit the rows that come back that meet some specific condition. This particular example doesn't include the where clause, but if you wanted to limit the rows that come back, all you have to do is include your where clause, and we saw how to do that in the prior lecture. So let's just go back real fast and look at that. Oh, sorry, that it lives inside of another place. So that is tool. So building feature, and then so that is just like this, where we put our where clause equals to whatever our where clause is, and the where clause is just an SQL statement. So I'll go back to where we were. Whoops, oh, wrong way. Oh, not caught in back button troubles. All right, search cursors, here we go. All right, so you can have a where clause to limit the results that come back from a search cursor, and you can also specify the fields that you would like. And in the for way of doing it, all we do is loop through all the rows that come back from the search cursor. Oops. So for each row in search cursor, do whatever is inside of this loop. And then the row on the inside is that particular row of the data that come back. So the first time you enter here, it's going to be the first item that came back. Second time, it's going to be the second item. Third time, it's going to be the third item. So you can access each of the data values in each of these fields using, in this case, index notation. So the 0, 1 is the name column, the 1 is the lot type, and then the 2 is the lot name. So here we're doing strange formatting, because there's 20 different ways to do everything in Python, so this is yet another way that you can do string formatting. So this is a super fancy print statement where we have placeholders, 0, 1, and 2, that are assigned values using our format function. So the first value here is going to go into the 0, second value is going to go into the 1, and third value is going to go into the 2. So we include all these little weird Python things just so you can see and not be scared of them for in the future when you're looking on Stack Overflow and people are writing their fancy Python code because they're fancy Python programmers. You can look at that and say, oh yeah, they're just doing string formatting. There's nothing exceptional about that, and I don't need to be worried about it. And then at the end, after we are finished with our loop, we have to delete the search cursor, otherwise that layer will be locked. So again, not super complicated. You specify the fields you would like returned. You say where to go get the data from, which layer, specify the fields you want, and optionally, if you would like to limit the results, you can put a where clause. If you don't put a where clause, it's just going to return all of the data. And do something with the data in a loop. So the other way of doing it is by keeping track of when iteration ends, with getting the next data row coming back by calling the next function on the search cursor. So this is a more complicated way of doing it, which is harder and, in my opinion, Doesn't really get you any additional benefit. It's just more of a pain to do this way. For streaming data, this makes more sense. When you just want to keep calling next, 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 next until there are no more data, then using next works better. But for a database that's coming back with rows, and it has a pretty predictable starting row and a pretty predictable ending row, this for me is overkill. Set it up the exact same way. Import ArcPy, set up your geodatabase, define the fields you would like to come back, create your search cursor with the location to search and the fields you would like back, and then you wrap this whole bad boy in a try-catch block. So what happens here in the first case is row is automatically set for us because we're using the for loop. So for something in something, the for loop handles creating a variable for each of the things in that thing until there are no more rows in that thing. The next way, you have to set what the row is by calling next on search cursor. So when you call next on the search cursor, it's going to go and get the next data item in its list. So the first time you call next, it's going to go get the first row. The next time you call next, it's going to go get the second row. The next time you call next, it's going to go and get the third row. And you don't know in advance how many rows there are because you can't do search cursor.length for reasons. I can't explain why that is, but it's a pain. So since you don't know how many rows there are, you can't know when to stop. So the only way that Python will know to stop is when you call next on search cursor, and search cursor says, I got no more rows, I'm going to throw up a stop iteration exception. And then at that point, you know to stop iterating. So this is a little bit different, and you have to manage the getting of the row yourself, but it, after that, does the exact same thing. So get the first row by calling next on search cursor initially, and then while you have a row, do stuff with it, and then to continue looping, you have to increment row. So you have to set row equal to next search cursor at the end of the loop, and then it's going to come back up and try to do it again, right? So first time you come in, row is set. So while row is going to be true, it's going to come in here, and then it's going to try to get the next row. And then it's going to loop back around, and if row is still true, meaning no exception has been thrown because we're out of rows, it's going to keep going. And then at the end of the second loop, it needs to go get the third row, so it's going to call row equals next. Row is now the third one, going to come back around, and if you only had 3 rows, here at the end of this loop, it's going to call row equals next. Next is going to say, error, no more rows, and then it's going to go into the stop iteration. So this is using exceptions to manage the flow of your code, which to me just seems dirty. You're not supposed to be, in my opinion, using exceptional cases as part of your programming. Exceptions are supposed to be exceptions that you don't expect to happen. So in my very specific opinion about this, this is the dirtiest programming because you are expecting an exception to happen and you're using that as part of your logic, which is just gross. So this way, with a for loop handling the getting of the rows for you, it's less code, it makes more sense. There are no exception cases that are actually, no, it's not really an exception because we're expecting that. It's cleaner, in my opinion. This is dirty. Don't do this. Do like a normal person and use a for loop. All right. Next up, we got update cursor. So update cursor is used for updating data in an existing data file or deleting data from existing data file. So if you're noticing, these are basically all the things you can do with SQL. You could do a select statement, you could do a insert statement, you could do a delete statement, you can do an update statement, So these are just funky ways of doing SQL on data sets that already exist. There's lots of other ways of doing this as well. This is a pretty common way that you'll see online when you're looking through Stack Overflow for how to solve a problem. People are going to be using cursors all the time. That's why we have a special lecture just on this. So update cursor is used to update some data inside of a database. So let's go through it. Starts off setting up the exact same way. So we import ArcPy, set our geodatabase. We select the fields that we would like to come back from a search, right? So an update cursor first does a search, but it also allows you to do an update. So it's search cursor. If you try to do an update or change any of the values, it's going to say not allowed. Because the search cursor is basically gives you a read-only copy back that you can't actually modify the data. The update cursor also does the search, but then allows you to modify the contents and then save them if you wish. So some of the saves might be to actually update some of the data values on that row or delete that row entirely. So that's the difference between a search cursor and an update cursor. They both do a search and give you a data table coming back. A search cursor only allows you to view the results. An update cursor allows you to view the results as well as change them and save them back to the source feature layer or shapefile or whatever. To make an update cursor, we're going to make a variable. I'm going to call a constructor of update cursor. I'm going to tell it where to get the layer, so which layer are we working on, and which fields we would like returned to us, because we don't need every friggin' field that's associated with the shapefile. You could also include a where clause here if you liked. So now, once we have the data we wanted back, we loop through it again. So we have for, we're going to use a for statement here because we're not idiots. So we're going to use the for loop. So for each row in the data that come back, do something, right? So if row 1, so if row lot type variable equals garage, then update that value inside of the 1 position to now be garage visitor. So this is going to loop through everything in our garage points feature layer. If the name or if the value inside of the lot type column is currently set to be garage, it's going to update it to be garage space visitor. And then if we want to save these results, we have to do update cursor.update row with the particular row that we have changed, right? So this is all inside of an if statement. So if the lot type is surface parking instead of garage, then it's never going to come in here and it's not going to change anything. But if the lot type variable or lot type column coming back inside of the data sets is garage, then we're going to reassign its value to be garage space visitor. Then we're going to click the save button basically and update that row. Then it's going to continue looping until there's no more to loop through, then it's going to be done. And at the end, we always have to delete our cursors, otherwise things get stuck. So you can see here, we are updating the value of an existing row in one of the columns of an existing row inside of an existing data set. So this is the way that you do that with Esri. So if you need to go through a data layer of any kind and add a new field and then calculate a value, or if you need to multiply something by 100 or whatever, whatever way you need to update the values associated with attributes inside of a shapefile, this will be the most common way that you see online. So 3 years from now, when you forget how to do this and you type in Python update feature layer, it's going to bring you to update cursor documentation basically. So you'll remember how to do all this. In this case, we're only updating a single value inside of the layer, but we can update however many layers that we want, or however many attributes that we want. We can update one of them or all of them if we wish. You can only update the field values of ones that you requested. So if you need to update something, or if you need to test one field in order to be able to update another one, you just have to make sure that you bring all of those fields back from the database or from the shapefile feature layer by including them in your fields list. Cool. So next up is delete. All right, works exactly the same way as update. So it's going to do a search, and then we're going to get rows. We're going to test something about that row. If it meets our test, then in this case, we're going to call delete row instead of update row. So we set up everything like normal. So we make an update cursor, and then in this case, if the value of 2, so if the value of lot name on our particular row equals century square, notice that we're using equal for the comparison, then we do update cursor dot delete row. Boom, the current row is now deleted. So again, this is risky. It's not going to prompt you and say, are you sure you would like to delete this row? Are you sure that you would like to delete this row? It's just going to go through and delete your row. And there's not going to be a backup. If you wish there to be a backup, there won't be. So you need to be very, very careful with your deletes, because you will remove data immediately. So update and delete work exactly the same. They do a search first, then you loop through. You have some condition that you're checking, unless you just want to update or delete everything. So the condition in this case is row 1's value in, is the row's value in column index 1 lot type equal, so use double equals, equal to garage. If so, reassign that value. So notice single equals here, and then update it. So store that data back to the database. Same thing down here. If row 2, so if row lot name equals century square, delete that bad boy, and then continue looping. So delete all garage points associated with that are named century square, and then at the end, delete your update cursor. So that's what cursors are. We spent a bit of time going through them because you're going to see them all over the internet when you're searching for ArcPy help. So without a discussion of what the different types are and what the differences are, then you might get confused which one to use for what thing. So they all work with existing data files that have already been created inside of a geodatabase or a shapefile or whatever. The insert one allows you to add more data into an existing file. The search cursor allows you to search through the data items inside of an existing file. And the update cursor allows you to update some of the existing rows inside of an existing data layer. And update includes both changing the values associated with some attributes in those rows and deleting some of the rows in that data layer. So important things to remember are it's helpful to pass in the field name lists that you would like returned, because working with all the fields can be a nightmare because you have to be able to index them, and you might forget that the 25th column is, this particular variable that you want to mess with. And then also available but not shown in these examples is the ability to pass in a where clause, which filters out the results that come back from your search cursors and your update cursors to just rows that meet the specific conditions that you are looking for. If you don't include your where clause, it's just going to return the whole data set to you. Some cases that's fine. Other cases you don't have to loop through the whole thing just to update one specific row. So that is search cursors. I guess the only other last weird part was keeping track of your own row with next. I'd recommend not doing that because it makes things harder for no good reason. In this particular instance, I'm sure other Python programmers have run into some kind of instance where it makes more sense to do next in your own row management. I don't know, how long am I doing this? In 16 years of GIS programming, I have never had an instance where I needed to do this. So if you do find one, congratulations, but I'm pretty sure I can make it work the way I like. Anyway, so that is cursors. Enjoy.